In this lesson, we are going to solve logs, solve problems that have logs in them. You got two different situations, and we're going to talk about down here how to deal with that. So two situations are you have logs on just one side, which is true on these four, or you have logs on both sides. So no matter what, so those are your two different situations, and we're going to approach them a little bit different. So when you're solving, the very first thing you have to do is condense. So if you have multiple logs, you have to make it look like that. All right, no matter what. So that's step one, regardless of the situation. So even on this one, we're going to condense it into something that looks like that. All right, so first thing, condense. And then if you have logs on one side, such as this, you're going to, every single time, rewrite it as an exponential. So we'll rewrite that as an exponential. Don't forget that the base of your log becomes the base of your exponent. Logs equal exponents. So it's going to become a to the y power equals the x. If you have logs on both sides, this might be a little bit of an easier type of problem, is once you condense, you're just going to drop the logs. So if you have logs on both sides, you just drop them and just focus on the values inside. So those are two different situations, and we're going to go through a couple examples. We have log just on one side. It's already condensed. There's no adding or subtracting like this one. So we're just going to rewrite it. So it's going to be 3 to the negative 2 equals x. And then we just solve it. So 3 to the negative 2, 3 squared is 9, but the negative exponent brings it down. So that's the answer. The only thing you got to double check for is extraneous solutions. So you can't log 0 and you can't log a negative. So you just want to make sure that 1/9 isn't going to be a problem. So 1/9 is positive, it's not 0. This should work fine. Same thing here. We just have logs on one side, so we'll rewrite it. So it's going to be 2 to the 5th power is going to equal 10 plus 3x. 2 to the 5th is 32 equals 10 plus 3x. We'll subtract 10. That's 22 equals 3x. Divide by 3. And we get x to equal 22 thirds. So 22 thirds is 7, a little over 7. We just, again, want to double check that we don't cause a negative to happen after we add these things together. And we definitely are not, because you're taking a positive plus another positive. So that should be fine. All right, here. So condensing. When we pull these two logs together, the plus forces us to multiply these two things together. So if it was subtraction, we'd be dividing these two. So this is a multiplication. So x times the x plus 3, so those two pieces are multiplying together, and that's going to equal 1. And then we're really at the exact same situation we were here. Let me just do one more step. And remember that there's no base on this, that's a base 10. If we multiply that together, that's x squared plus 3x equaling 1. So it really has that look to it. So we rewrite it, so it's 10 to the 1st equals x squared plus 3x. We got ourselves a quadratic, and this is where you have a tendency to have problems that solutions that don't work. Not always, but this definitely time you want to double check and make sure you're good. So we'll subtract the 10 over, so that's going to be a 0 plus 3x minus 10, and then it's factorable. So what multiplies a negative 10 that adds to 3? That would be a 5 and a 2. And we would need a positive 5 and a negative 2. So then if you set those factors equal to 0 and get your solutions, you'd have a negative 5 and a positive 2. All right, so we have two answers. Sometimes two answers work, sometimes two answers don't work, sometimes none of the answers work. So the negative 5 is a problem because you can't log a negative 5. So that is an extraneous solution and it gets kicked out. And so even a positive number doesn't always guarantee it, because if that was a 2 minus a 3, you'd have a negative value and you wouldn't be able to have an answer there. But you get a positive here, that is just fine. All right. And then we'll do another video with a little bit more challenging types of problems.